Hello, my name is Reinhard, GM Runkat. I am a student in the Information Systems program, Faculty of Mathematics and Natural Sciences at Sam Ratchalangi University. I am from Class B, with a student ID 24,101,106,057. Today, I will be explaining the topic of transistor. A transistor is a semiconductor device that can amplify or switch electronic signals and electrical power. The most common types of transistors are bipolar junction transistors, BJTs, and field effect transistors. Key principles. Structure. A transistor typically consists of 3 layers of semiconductor material, forming 2 p-n junctions. In a BJT, these layers are called the emitter, base, and collector. In a FET, the layers include the source, gate, and drain. Operation. The operation of a transistor is based on the control of current or voltage. In a BJT, a small input current at the base controls a larger current flowing between the collector and emitter. In a FET, a voltage applied to the gate controls the flow of current between the source and drain. Switching and amplification. Switching. Transistors can act as electronic switches. When a small input signal is applied, the transistor can either allow current to flow on state or block it off state. Amplification. Transistors can amplify signals. A small input current can control a much larger output current, making them essential in audio and radio frequency applications. Transistors form the building blocks of modern electronic devices, including computers, smartphones, and various digital circuits. Logic gates. Logic gates are the fundamental building blocks of digital circuits. They perform basic logical functions that are fundamental to digital circuits. Here, we will explain 3 basic logic gates. NOT and O are NOT gate. Symbol. The NOT gate is represented by a triangle pointing to the right with a small circle representing inversion. At the output. Function. The NOT gate takes a single input and produces an output that is the opposite, inverted, of the input. Example. If the input is 1 true, the output will be 0 false, and vice versa. And gate. Symbol. The AND gate is represented by a flat-ended shape with 2 inputs on the left and 1 output on the right. Function. The AND gate takes 2 inputs and produces an output that is true 1. Only when both inputs are true 1. Example. If both inputs are 1, the output will be 1. Otherwise, the output will be 0. OR gate. Symbol. The OR gate is represented by a curved shape with 2 inputs on the left and 1 output on the right. Function. The OR gate takes 2 inputs and produces an output that is true 1. If at least 1 input is true 1. Example. If either or both inputs are 1, the output will be 1. If both are 0, the output will be 0. These logic gates can be combined in various ways to create complex digital circuits that perform a wide range of functions, from simple calculations to complex decision-making processes in computers.